Hello, this is Miss Malatin from Freedom High School Chemistry. Today we're going to look very carefully at single replacement reactions. More specifically, at metal to metal replacement. This is where you have a lone element and a compound that's in solution, and the lone element replaces the metal in the compound, and the metal from the in the reactants compound becomes a metal by itself in the products. Halide-halide is very similar, except our lone element is a nonmetal, and we have a compound with a metal and nonmetal, and that lone element nonmetal takes the nonmetal spot, the anion spot. And what was part of the compound is now a lone element. So we remember that collision theory, particles must collide in order to react, and they have to have proper orientation and sufficient energy. So we're going to assume today that we are having collisions, and we'll talk about why, and proper orientation, and we need to look at the energy and whether this will happen or will not happen. We are predicting. So let's look at our first one. We have here aluminum, solid aluminum is reacting with copper chloride that is in an aqueous solution. We want to remember that more reactive metals that are more reactive, they easily lose electrons. So what's going to happen in this case is we have the copper and we have chlorine. This is just one formula unit and one aluminum. They are in solution, they are dissolved, they are being pulled apart by water molecules. The copper is attracted to the negative side of the water molecules, the chlorine attracted to the positive side, and that's what's keeping it dissolved in solution. We're going to put the aluminum in that copper solution. We're going to have collisions. That copper is going to bump into, because remember, that water is continuously jostling these ions around. So we'll have a collision. And because copper and aluminum have different activities, the copper has a greater attraction for the electrons. So aluminum is more active, which means more active, it has a more active metal, has less attraction for electrons, and easily loses electrons. So the copper gains the electrons and aluminum loses it. What that ends up meaning for what we see is the copper is no longer an ion, it is no longer attracted to the water, so it's no longer in solution and it just settles down as a metal. Aluminum is now in solution, it has a positive charge, and so it is attracted to the negative side of the water, and now it's in solution with the chlorine. So that's what's happening at the molecular level. Let's talk about what we would do to predict this and how we would predict and see what our balanced chemical equation would be. So all these predicting, our first step is determine the type of reaction. Well, right here, number one, let's zoom in a little bit. Number one, we have aluminum and copper chloride. We have a single element and it's a metal, so this can only be one type of reaction. This is going to be our metal-metal replacement. The aluminum is in the A spot, and it's going to replace the copper in the B spot. And so let's predict we have AC plus B. So first thing we do is we're going to say, well, the aluminum is going to go with the chlorine, and then the copper will be by itself. Well, how do we know this is going to happen? Well, what we need to do, zoom that out, what we need to do is we need to look at our activity series. So we determine the type of reaction. We decided it's a metal to metal single replacement. We are going to use the bonding rules to determine the products. Let's remember the swap and drop or diatomic ions, diatomic molecules, etc. So let's take a look. We ignore this. We are going to look aluminum and chlorine. That's a metal plus nonmetal. Aluminum is going to be a +3, chlorine a -1. So we swap and we're going to drop. So we have AlCl3. Copper is a metal, and we know the formula for metals is just by itself. All right, so we now decided this is a single replacement, and we predicted our products. So we want to see if this will occur. So we have to check our activity series. This will only occur if aluminum is more active than copper. This means if aluminum does not have as good of a hold on the electron as its electrons as copper. So let's find aluminum. Here's aluminum, Al, and copper is way down here. So aluminum is way more active than copper, and so this reaction will occur. Our last step after that is balance. And so we can just do a quick balance. AlCuCl. 1, 1, 2. And 3. That's just Cl3. And so pretty quickly, I'm going to put a 2 here. Make this a 6, 2. Cl, put a 3 here. 3 and 6. Now I just have to match up my aluminums and my coppers. I have 3 and 2. And we are pretty much balanced. So that is a metal-metal. Let's take a look at a halide-halide. So how we recognize this is we have a compound plus a single element, and this single element is a halogen. And so we have a determine the type of reaction is step 1, and we've determined this is a halogen-halogen, that the single element by itself is a halogen, so it can replace the other halogen. We're going to use the bonding rules to determine the products. So we're replacing with K, and I have F plus Br. Br is a diatomic molecule. We know it's got to be Br2. Kf is a pretty easy one. K plus F minus, swap and drop, so it's just Kf. So right then, we just use the bonding rules to determine the products. Now we got to check to see, will this reaction actually occur? Well, we need our activity series. This is a little easier. Now metals, nonmetals, more reactive nonmetals easily gain electrons. So these are going to try to grab these electrons. So let's see, we have fluorine is way more reactive than bromine. So this is going to happen. This is a reaction that will happen. So we have predicted, determine the type, and so now we have to check to see if it happened, and now we just have to balance. This is a pretty easy one to balance. I'll just leave that to you. And you can finish that one up. And so that is how you predict metal-metal or halide-halide single replacement reactions.